So at this point, we're going to stop because we're just warming up to this point. We just want to build these, we want to take this information and just build the inequalities and the one equation. And what we're going to do is in the next couple examples, figure out what to go from this point. Okay, but let's just try this again where we're just building equations. We're going to read a problem and build some equations. So let's look at number 5, also just right below that. If you want to pause this and see what you can do, first of all, declare your variables. What do you want x to be? What do you want y to be? And see if you can find that one equation and a couple inequalities. Well, here with example number 5, it looks like we have a furniture company that wants to manufacture dining tables and chairs. And if you go to the very last sentence, it says how many tables and how many chairs should Winston manufacture in order to maximize its profits. So if we let just our variables x be the number of tables, y is the number of chairs, and what we want to do is maximize our profit. So again, we're going to have a profit equation. Everything else is going to be in the form of inequality. So let's read through this. Each table is going to require 40 feet of wood and 3 labor hours. Each chair requires 16 board feet of wood and 4 labor hours. We have a profit for each table is $45 and a profit for each chair is $20. Okay, so it looks like we can, let's start out with that profit equation. We already got all the information right there. I'm going to go P equals again just because P for profit. And for each chair, or for the profit for each table, so we're going to make $45 per table, so 45x, and the profit for each chair is 20, so 20y. All right, we've got the equation done. Let's see if we can go now and get the inequalities here. And it says in a certain week, the company has 3,200 board feet of wood available. Okay, so it's talking about it has a total of 3,200 feet of wood that it can use, whether it's going to go, however much is going to go towards the table, however much is going to go towards the chairs. All we know is we have a total of 3,200 feet of wood. So let's go back into the problem and read again some more of where does it talk about the wood feet. Well, it says each table requires 40 feet of wood. So 40 feet per table plus, and then going to the chairs require 16 feet. So 40 feet of wood for each table, 16 feet of wood for each chair, and we don't want to say equals 3,200, so we don't have to use all 3,200. All we know is we have at most 3,200 to use. All right, and the last part says it has 520 labor hours. So let's go back up and pick out the labor hours. Each table requires 3, so 3 labor hours per table plus 4 labor hours per chair, and we have a grand total, so we know it has to be at most 520 total labor hours that we're going to use. Okay, so 2 inequalities right there. Looks like we have all of our information used up. All the profit stuff is with the profit equation. All the hours are with the hours inequality. All the feet of wood is with the feet of wood inequality. And last but not least, just like we did before, x for sure has to be greater than or equal to 0 because you can't create a negative number of tables and you can't create a negative number of chairs. And there you go. All right, let's try this one more time. Let's look at number 8. It looks like in this example, number 8 in the book, what we're doing is we're trying to decide, we have at most $500,000, and what we want to do is separate this into 2 different funds. Some of it's going to go to Project A, and some is going to go to Project B. We just don't know how much. Well, it says in the very last sentence is how much is she going to invest in both of either one or the other. Okay, so if X is the amount that's going to go, obviously in the first one, we'll say Project A, and Y is the amount in Project B, then we know that together, X plus Y, instead of being equal to 500,000, we're just going to say, they just say it has to be invested up to. So we'll just say less than or equal to the $500,000. Okay? All right, that takes care of that, and I'm just going to kind of go it piece by piece. The next portion it talks about is it wants to all about is how to maximize the return. You know, the return is what you get in interest off of letting the bank loan you money or you loaning the bank money. It's all about the return. It's your interest. So I'm going to say I equals, I for interest, kind of like before I did P for profit. I is interest, and it says Project A yields a 10% return on all of its investments. So 10% of, so 10% times X, 10% of all that's invested in project A, you're going to get 10% back of it. And then, for a fact, we know with project B, we're going to get 15% back. It's a little riskier, but we're going to get 15% back. So 15% of everything that I invest in project B, I'm going to get 15% back. All right, so that's how we're going to use those, because it's all about interest, it's all about rate of returns. All right, let's go further into this and see what we can do as far as another inequality possibly. It says because the investment in project B, so in Y, is riskier than in project A, which is X, the financier has decided that the investment in project B should not exceed, so the investment in project B, the amount of money, so Y, should not exceed 40% of the total investment. So whatever you put in project B needs to be less than or equal to, because it can't be exceeded, it has to be smaller than that, 40%, so 0.40 of the total investment. Well, the total investment is X plus Y. Right there. That's the tricky part to all of this, is we've got to say 40% of the total investment, not 40% of X or 40% of Y, but of together X plus Y. And we don't want to say 40% of $500,000 because we don't know she's going to be investing all of the $500,000. All we know is she's going to be investing just so much in each one, just X in this one and Y in that one, that's it. And then like before, as always, we got a word problem. I can only invest positive dollars in one and positive dollars in the other. And so here's your system of equations, and here is your one equation that can be used to maximize the rate of return. All right, let's go on to the next example. Okay, so hopefully with here, number 13, the book, you've got a chance to kind of read through it, and you looked at the very, very last sentence, and it says basically that how much water should the manager get, this manager of this Midwest city, from each source to minimize the daily water costs. So we're going to minimize costs this time. There's going to be our equation, and we have two sources that we're getting water from. We're getting water from a reservoir, and we're getting water from a pipeline. Okay, so going through there, we'll start from the very, very, very top, and let's see what we can do as far as inequalities. First thing it says is we need to, that the Midwest city, we need to supply the city with at least 10 million gallons of water per day. So the amount of water coming from each source, the amount coming from the reservoir, and the amount coming from the pipeline needs to be, and this time it says at least 10 million. So it needs greater than or equal to. And right here, I'm going to try to just keep it in terms of tens. What we can do is just say all the units here are going to be in millions. So water amount from the reservoir, what we can say is, quote, in millions. And then the same thing from the pipeline is going to be in terms of millions. And that just keeps me from having to, over in that inequality, literally write it saying X plus Y is going to be greater than or equal to, and then 10, 0, 0, 0, 0, 0, 0. If we leave it all in millions, then we can just say, okay, the unit on that whole inequality is, you know, the millions of gallons from the reservoir plus millions of gallons from the pipeline needs to be greater than or equal to 10 millions of gallons, okay? All right, next. The supply may be drawn from a reservoir or pipeline, okay? The local reservoir, so X, has a maximum daily yield of 5 million gallons, and the pipeline has a maximum daily yield of 10 million gallons. So the most that you can pull from the reservoir is 5 million. So the amount coming from the reservoir has to be less than or equal to 5. The amount coming from the pipeline, which is Y, it says its maximum yield is 10 million. So it has to be less than or equal to 10 million gallons. Again, because everything's in terms of millions of gallons, all I have to do is 5 and 10. By contract, the pipeline is required to supply a minimum of 6 million gallons a day. So it can at most give out 10, but it has to give at least 6. So the amount coming from the pipeline is going to be somewhere between 6 and 10 million gallons. All right. And one other thing we can do, at least with the X's, because there's no lower bound on the amount of water coming from the reservoir, we can at least say it has to be greater than or equal to 0, because you can't pull a negative amount of gallons of waters from a reservoir. Okay, so that helps out a little bit there. All right, last but not least, it talks about if the cost, we're going to want to minimize cost. So the next part, since it's talking about cost, we're probably going to do our cost equation. If the cost per 1 million gallon of reservoir water is $300, So the cost C is going to be $300 per million of gallons of X, and for the pipeline, it's going to be plus 500 per million gallon from the pipeline. And there you go. That's going to give us our cost equation. We have $300 per million gallon per 1 million gallons of reservoir water and $500 per 1 million gallons of pipeline water. And we already incorporated back up into our three inequalities the fact that our variables had to be positive. Specifically, X is going to be greater than 0 but less than 5 because we have a maximum yield. And then for the Y, they gave us a lower bound of 6. Otherwise, if they didn't give us a low minimum bound, we would put zeros for there as well. All right, let's do this one more time. Just to get one more chance of practice, and then what we're going to do is go and finish carrying this out the rest of the way and figure out, okay, what do we do from this step on now that we're kind of figuring out how to draw this up. So let's look at number 20 in the book. If you want to pause it, let's form our variables and see if you can for sure get the inequalities and check it with me. Well, I just went through, and as I was reading it, I kind of just wrote out what I thought everything should be. The very last sentence says that she wants to maximize the return of her investment, so how much should Ashley invest in each type of fund? Well, there are three types of funds. Now we have three variables, X, Y, and Z. X is going to be the amount invested at the money market. Y is the amount of dollars invested in the international equity fund. And then Z is going to be the dollar amount invested in the growth and income fund. Okay, so we have three different funds, and each of these funds have their own rate of return, so I made sure I wrote those out to the side. And the whole goal with this is we want to maximize our return, which is the same thing as maximizing the interest we get back, because the interest is what we're getting by letting the bank borrow our money. All right, so let's start from the first part. It says Ashley has earmarked at most $250,000. So what she can invest totally across all three of those funds has to be equal to or smaller than $250,000. Makes sense. She can't invest more than $250,000 if she doesn't have it. So it's got to be at least smaller than $250,000. And then it talks all about we want to maximize. Let's go ahead and get that equation going on according to our interest values. So if we want to maximize interest, then our maximum interest, our interest equation is going to be all about how I'm getting interest from each of the funds. Well, we're getting 6% off of the money invested in the money market, so 6% of X plus 10% of Y, the amount of money in the international, and then plus 15% we get off of the growth income fund. So there's our equation. Now the next piece of information after we get through all of that, it says Ashley has stipulated that no more than 25%, so either at most 25% of her total portfolio should be in the growth and income fund. Okay, so the growth and income fund, which is Z, so the amount of money that she puts in Z has to stay below, so it can't exceed 25%, so 0.25 of, we're going to multiply her total portfolio, where her total portfolio is what she's investing in all three of these accounts. Okay, so the amount of money that she's investing in the growth and income can be no more, so less than or equal to 25% of her total investment. All right, and the next part she says is no more than 50% of her total portfolio should be in the international equity fund. So the international equity fund is Y, so the amount of money that she's putting in Y can't be anything more than 50% of our total investment, which is X plus Y plus Z. Okay, so that pretty much takes care of all of this, and all that we want to obviously do is just say, if we want to put this in general, X, Y, and Z, all three of those obviously have to be greater than or equal to 0, in the sense of you can only invest positive dollar amounts. Okay, I'm going to stop this video right now, and where I'm going to pick up is on the next part of this, part 2, is right here at this point where we're going to take now, we're going to go to forming our equations, and then from forming our equations, we're actually going to graph and solve it from here.